Hello, everybody. Welcome to our webinar today, Beyond the Finish, Designing Furniture That Performs. My name is Joe Agati. I'm the CEO here at Agati Furniture. We want to talk to you today about designing furniture for public spaces. For those of you that know Agati, we've been around for a little over 40 years now, and mostly since in the company's inception, we've been focused on designing furniture for public space environments. We got our start in libraries, decades and decades ago, and have grown beyond that into other markets, higher ed, K-12, courthouses, aviation. But again, always focused on the public space environment. So today, like I said, we're going to be talking about designing for that public space. The challenge is that in an ideal design world, we like to balance out aesthetics, function, and durability, right? All that should live in harmony with itself. The reality is we tend to choose furniture based on aesthetics. There's nothing wrong with that. I am known to pick things that I think look nice or I find visually appealing. I think we all do that as human beings. And then we kind of look at function, and then does it work for our lives, our environment, what's going on, and then will it last? I think this has been exacerbated too by our culture, and that we are definitely living in a throw it away type society, unfortunately. The challenge with that approach, though, when it comes to public space furniture, is that we really can be weighting aesthetics the heaviest. It's important. I'm not advocating to buy ugly furniture or make a space that doesn't feel or look inviting. But really thinking about the public space, how's it going to function? But really thinking about the durability of the product. So again, we're going into environments that could be 24/7 use, high abuse spaces. And again, they're public. They're not owned by anybody. So especially when we even, people that care quite a bit, if they're in a public space environment, that since that lack of ownership's there, not there, you're not going to take care of it as nice as you would when you purchased it and invested into it. So designing for public spaces, we want to think about durability and maintenance. And those are kind of the two areas we're going to talk about. We're going to spend a lot of time on durability. You saw in the bubbles earlier that durability is the most important. So we're going to go deep into that. And then we're going to talk about that other side of that. Listen, no matter how durable we make this stuff, the reality is you're still going to have to be able to maintain it. So from a durability standpoint, there's three factors that'll affect it. People being number one, and that's pretty obvious, right? People are going to be the most abusive in public space. Cleaning, which seems kind of counterintuitive, right? I'm cleaning it. I'm trying to maybe maintain it, make the product last longer, look nicer longer. But cleaning can have a negative return on the product. And then food. So allowing food into the space, again, that's from a big bucket standpoint of what's going on in there. If you're having food or food service in the environment, that's going to add another level, again, of cleaning and abuse for people. So I want to look at basic construction, talk about vulnerable points in products, and what we are recommending based on our years of experience and observations. So now I want to state that everything here is done here at a very high level. It took time to just boil this down into just under an hour presentation. So you can go really deep into some of these categories. So I encourage people, if they have other questions, they can follow up with me through our website or whatnot. We're always happy to talk about these topics. So we'll just keep in mind when we're going through this, we're doing it at a very high level here. So from that, under construction, vulnerability, and recommendation, we're going to look at tables, seating, workstations. We broke out fabric. Not that fabric is to be found on tables, but it's found on seating and workstations. But it can be kind of its own unique animal. And then power being separate from that. Again, power is a subset of these of furniture almost all the time. But there is enough complexity to it that we kind of broke it out in its own segment. So tables. Like I said, talking about from a high level, broad perspective. So looking at construction, being tables are going to come in usually at top and then a base. The tops can vary in shape, size, material, base the same shape, size, and materials. But those are the basic components of a table, not earth-shattering information that I think people don't already know. But looking at tops, usually the top is going to be broken out into one of these three buckets. Some kind of laminated top, where you see the laminate and veneer kind of off to the left here. Some kind of engineered material, could be stone, quartz, engineered stone, quartz, solid surface, something like that. And then we put solid wood in its own kind of category. Solid wood's great in the public space environments. We don't run into a ton of solid wood as a tabletop material, but we do it from time to time. It is beautiful, and if you can afford it, it's great. But it had some uniqueness to it, so we broke it out into its own kind of subject here. So think about basic construction of these laminated top materials. You're gonna have a top face, could be veneer, could be laminate. We don't see it as much anymore. Linoleum as a material that would be applied to this. That was really big in like 90s, early 2000s. We don't do a ton of it, but it is an option out there. Edges can range. Obviously, you can have a PVC edge that you see on top here, wood edge that you see down below. There can be urethane edges, which is a cast edge. You could do, you can take laminate, put the laminate on the edge. Again, we don't see a ton of that anymore because PVC edges have come so far now. But those are the big ones: wood, PVC, urethane, laminate are the ones that you're going to run into the most. There's usually a bottom face, a phenolic backer or paper backer. That's to balance out the board. You really want to enclose all those surfaces as much as possible to keep the board balanced from warping or mushrooming or bowing in there. And then there's a core material. Particle board, MDF, or plywood are usually the core materials that you're going to run into with this type of construction. So moving on to typically the fancier kind of top materials being a solid surface engineered stone of some sort in there that, usually they're going to come in 12 millimeters. So solid surface pretty much almost always comes in 12 millimeters thick, about ½ inch thick. There are some now that you can get out there closer to 3/4 of an inch thick. And then your stones are usually going to be 1 to 2 to 3 centimeters for the engineered stones. And then usually if you're doing it thicker, if you see that thicker profile, you're going to see that like kind of built up edge. So that image off to the left there is showing how you would build that edge up. So for solid surface, you take it and you turn it and then you make it look thicker. You're not actually stacking just full layers of stone or solid surface in there to make it that thickness. You're either turning the stone or turning the solid surface and then getting the height that you want in there. And then under basic construction, you're usually gonna have to like define an edge detail, and this can range, so you can do ease, bullnose, knife, OG, all kinds of different edges. This will just be depending on people's kind of machining capability and tooling that they have in there. So typically you're gonna want to, or someone's gonna ask you what edge detail you want to have. If they don't, they're probably gonna default to an eased edge in there, but you want to just kind of verify that. So with the solid wood, again, solid woods can range in thickness. You don't really see people doing it too much less, not much less than 3/4. It just has to go with the stability of the wood in there, and you can get them up to 3 inches plus thick in there. So it's a pretty wide range. We'll talk about vulnerabilities and recommendations on that range in there in a little bit here. And then again, the edge profile, similar to the engineered stones and solid surfaces, you can pick an edge and define an edge profile. I didn't put this in here, but as an icon, but yes, defining a radius is probably the most common of which you're going to run into. And again, we'll get into that when we talk about recommendations. With the solid wood, you have this extra component of board width. So sometimes people will go down as thin as 3/4. That's, and then you're using those, it's going to give you more of that butcher block type look in there. And a lot of times that's an aesthetic choice that you want that kind of very striped look. And then you can go like, up to 6 inches wide in there. I mean, if you're using softer woods, you can go wider in there, but you can have that range. And again, we'll get into a little more definition of that when we talk about recommendations. And we put this in the solid wood top category, but you'd have to do the same thing for the veneer if you're doing a veneer and solid wood edge top material. But you're going to have anything with the wood, you're going to have a finishing step that has to happen. And I just want to put out there that finishing is probably the most complicated thing in constructing things out of wood. It's really hard because it's less of a science and way more of an art form. I think a lot of people that don't work with wood on a regular basis don't always understand like the variability that you're getting out of these trees, especially when you're working with oaks. They can range very wildly in color and grain in there. So really that finish has to be applied to try to make it somewhat uniform. And then that's where you're finishing it. So it can be pretty complicated. Um, but nonetheless, what it is usually a coloring that goes on top. Sometimes even if they call it clear on top, sometimes people will still put a toner again to try to address the variability in color that you may be getting across solids and veneers across an entire project. So that color can be either sprayed or wiped. It's really going to kind of depend on fabricator setup and the material and the color you're trying to hit in there. It's really complicated, especially as laminates have come such a long way and they look really great and they kind of look like wood, but they're not really wood. And so trying to match them can be really challenging. And then you're going to come back with a top coat spray. So then basically you're going to have your color and then you're going to seal it all in. And then the top coat is what's providing your durability in that. So vulnerable points, looking at different top options. So how these are going to be vulnerable in the public space. So your top faces, everything's going to touch it, right? So it's vulnerable from every kind of perspective, people, cleaning, and food service. And the food service ties directly into the cleaning. The more food, the more cleaning you're going to need, the more people are going to damage it. So just keep that in mind as you're thinking about how you want to allow different things into your environment. Edges, again, things that are going to, destroy your edges are going to be people, abuse, unintended abuse, but abuse nonetheless. And then cleaning, right? Especially if it's a wood, you're going to have a finish on that wood. Even if it's laminate and then up to wood, you still have a small section of finish there that you have to manage. We'll talk more about that in recommendations here. So for the engineered materials, stone, solid surface, thing like that, people in food service will kind of damage it the most. People will tend to scratch, especially if it's solid surface because it's softer, we'll put scratches in it. So usually I recommend more of a lighter color. Solid surface is also prone to staining. It can stain. I believe you can always get it out. You can sand it, buff it back out. That's kind of the pitch with solid surface is that it theoretically has this maintainability, but sometimes it could be a lot to maintain compared to like an engineered stone of some sort. Edge, again, it's going to be the people abuse. That's going to be your next most vulnerable point in there. And, especially on an engineered stone, your top surface, I mean, it takes a lot to damage that. But really where you're going to see the damage first is right on that edge. We'll talk about how to manage that in recommendations here. And then your wood, material, solid wood, and even if it was the veneer and a solid wood edge makeup, again, all three are gonna hit it in there, and you're gonna play that cycle of cleaning food cleaning back to people, and then that's what starts to loosen the finish and then cause damage in there. Then your edge, again, the more blunt that edge is, the more it's going to take damage from people. And again, because it's got a finish on it, the cleaning could disrupt and loosen that top layer in there. The benefit of the solid wood is they are easier being the key, not easier to refinish. You can actually just take that solid wood top off, run it through a sander, and kind of just re-go. The veneers don't really allow you to do that as easily, just because they're so much thinner in there. So that's sometimes why people will like to go to solid wood tops, but it is still a cost to do. So what do we recommend? So knowing all of this, based on our kind of experience, especially now in post-COVID world, which seems like a long time ago, but our behaviors have changed in these environments, especially the public space. Laminate is really a great way to go with a textured finish for the inset material in there. We still do some veneer work, but it's usually in a very specialized situation like reading rooms, archival rooms, stuff where it's a very controlled environment, both behavior and cleaning in there. From an edge standpoint, PVC works really great. I know it's not the best for the environment. I get it. As a closeted environmental nut, I completely understand. But it is fairly universal. It does match the very universal matches. There's a lot of suppliers of it. It is a small amount on the work surface in there, but it does a great job of protecting that edge. Urethane edges are a great option too. They're usually not the most aesthetically pleasing, but they're very durable. Solid wood is still good. There's nothing really necessarily wrong with solid wood. Just know that like there is still that finished component that you may have to manage too in there. And then radius, you've heard me mention edge profiles, really trying to have an 1/8 inch radius on these edges. So on that wood there, you can see that is like just I would say the bare minimum of what we would want on a radius. I don't want it any smaller than that. That what's on top of that PVC edge and the white there is probably closer. I know it's not the most aesthetically pleasing, especially when you first get into the environment. But it will hold up a lot longer over time because the sharper that radius is, the faster it's going to show a nick or a dent into it. So you'll see a theme here with 1/8 inch radiuses coming up. And then core materials, we do use a lot of particle board. But really, when you're doing that, you want to make sure people have a pretty dense 35 to 45 pound particle board. I think most of the time we're pretty much exclusively using 45 pound. There may be exceptions to that here and there, but we want to make sure we got a really dense one. MDF is good. Again, it's going to be really dense. You don't always get the same screw bite into it. That's why we like to use particle board more. Plywood is good too. The problem with plywood is going to have voids in it, but all three are acceptable and could be used interchangeably depending on construction. And again, recommendation on the engineered materials like the engineered stones and solid surfaces. They all have their pros and cons, and they're again, just at a high level, all have their place. But really what comes down to the recommendation is you gotta treat that edge well, because that's what's going to show the most wear and tear. And the sharper it is, the faster it's going to chip or crack or break, in there. So 1/8 inch radius or greater on there is always a good option. And then thicknesses, solid surface pretty much always comes in 12 millimeters, and then you're building up the edge. So that's fine. It works. You're going to put a sub top underneath it most of the time anyways. We don't like to go less than 2 centimeters on our quartz. And there are more out there, that are thinner, which are probably fine. But for what we're trying to do with public space, you can crack them, especially if they're not supported well. So 2 centimeters is a great kind of balance in there between the 3 and the 1. And then you can build up the edge as needed. And then for the solid wood, 3/4 is usually the minimum. I know you can get some thinner ones out there. I'd be worried about the stability. 2 inches thick is great. You can go thicker. That's kind of an aesthetic choice at that point, in there. 1.5 to 2 inches thick gives you some ability if you wanted to potentially refinish it 10, 20, 30 years later. You got enough material to kind of do that in there. And then again, edges, 1/8 inch radius or greater. And then on the board width, we like to do a varied board width, 3 to 6 inches. 1, 2, it gives a little more stability in the board and the top. And 2, it makes it easier in selecting the wood, especially if you're doing long tops. You just think about you're cutting that out of a tree, so you're really, the longer the top is, the longer stretch you need to find of wood that doesn't have a crack or an imperfection in there. So it also helps with some of the yield. So 3 to 6 inches, especially varying it in there, will produce a nice looking top. So that's tabletops. So the next thing we're going to go down is the base, which is the next major component of the table. So usually, and again, we're looking at big buckets, you're going to have a panel-based type table, a solid wood table, probably going to be 4 legs, most likely, or some kind of leg construction, and then metal. Again, these are kind of just big bucket categories, but this is how most table bases are going to be constructed. So looking at the basic construction, panel-based, again, being that kind of flat panel that kind of comes down in there. Solid wood being, more like 4-legged tables. Off to the right, there you have a trestle type base table in there. And then metal being most likely 4 legs. We did include a power bar. This is a power bar that we make here that kind of falls into both categories, panel and metal. You don't find a lot of panel-based tables made out of metal. It's just not a common construction. But there are some out there. So that's why I make you aware of that kind of configuration. So 4 legs versus end assembly, or panel. So 4-leg being 4 individual legs, like you see there. And just so we understand terminology, it's going to be like that panel or end assembly. End assembly being that the fact that the legs are going to be connected by a stretcher in there. So while it looks like 4 legs, it's actually 2 leg components that are connected there. So that's kind of how tables will be constructed most of the time. so to a varying degree, being the legs independent, and then either the panel or assemblies having a stretcher component underneath the table. So vulnerabilities. So when we look at this, we're just talking about the bases right now. So people and cleaning, and it's mostly going to be people, and people that are actually doing the cleaning are what's going to kind of abuse this the most. So people either bumping into it or people using cleaning apparatuses like vacuums or floor polishers bumping into it is really what's going to cause damage to the legs. Even though they're kind of in high traffic areas, they don't tend to show as much wear. A lot of the wear is going to come into the work surface, obviously. That's getting the most abuse. So looking at vulnerabilities and getting deeper into kind of the construction a little bit. So on the four-leg table, there's kind of a rule that we follow to deal with like what we call racking, the left to right flexing of the table base in there, and then looking at kind of the stretcher and assembly construction, talking about number of stretchers and height. So I'm going to come back to specifics on that, but looking at recommendations, again, the theme, 1/8 inch radius or greater is really a good place to start. Even in the metal, the sharper the metal edges and you put a finish on there, that finish is going to chip. So if you can be closer to an 1/8 inch radius, that really helps the longevity of it. The wood in the center here is kind of almost a full radius in there. When we do that, we don't really see a lot of wear and tear on the legs. And then on the panel base, this is representing a plastic laminate panel with PVC edge. Again, 1/8 inch radius in there. We do table panels that are thicker. We'll solid wood edge them. Again, having that 1/8 inch radius on there is going to help reduce that kind of denting that you'll see in the material over time. So like we said, edge face could be PVC, solid wood. Sometimes you do metal. We've not really constructed tables that way, but you can. I've seen them out there, and it's an acceptable way to do it. So for four legs, what we always recommend, that's why on the vulnerability side, if you go too big in the depth and the width, you're going to get that racking in the table. So we tend to like to stay under 48 inches and under 60 inches. So under 48 inches in the depth and under 60 inches in the width. If you're under that, you should be able to construct the leg with enough strength to stop the kind of left to right kind of racking or movement in it, and then also have enough support in the top under its own strength, or put reinforcement underneath there to support the top in there. So if you're going bigger in any one of those directions, you want to think about putting a stretcher in there, but that's going to pull you into the leg assembly realm. The reason we talk about this is sometimes people want to put people all the way around the table on all sides. And so when you start doing that and you start going over certain sizes, you may lose some of that ability. Also, when you start adding in stretchers, you're going to lose ADA capabilities. So if you're under 42 inches, if you want to have it ADA accessible, you want to make sure the stretcher's offset to one side. In there by 19 inches. And that's, again, not going to hurt anything, and an acceptable way to construct the table. And it won't disrupt the person on the other side. These stretchers don't hang that far down that it's going to become a knee knocker or knee blocker, and you can make the table ADA accessible on one side there. As you go over 42 inches, then you can bring two stretchers in. And again, we like to push them back 19 inches. It's a compromise to try to make the table fully accessible to people. Ideally, it would be nicer to bring the stretchers closer to the edge to, help stabilize the table. But 19 inches works in there. And again, it's a good balance to not only achieve the strength and durability needed in the table, but then also making it accessible for folks as well. And then looking at height, like we said. So if it's metal, 2.5 inches works in there. Wood, I like 6-inch stretchers. You can cheat them to 5. I like the thicker ones. It both helps with top stability, but also helps with the racking of the table, pulling the flex out of the wood in there. There is an exception to this rule, and I bring it up because we have tables like this. Other people make tables like this, and it is an acceptable way to do it. There are some unique elements that I want to point out, being that you can break the 48 and 60-inch rule when it comes to these four-legged tables here. So you can do them. You could do them wider, 60 inches in depth. It's rare to get tables much deeper than 60 inches. People do it. That's usually a board width, but you can get boards 60 inches deep. And then greater than 60 inches wide is a common way that you'll see the tables constructed, obviously. But the key is that if you have the legs, 4 independent legs pointed in. So what's happening in space there, that's now kind of tricking the table, and you're creating a lot of strength in the left to right racking direction of the table. So you'll get a lot of good stability. Then it comes down to strengthening the top. So you need to reinforce the top when you're doing these. You have to do, especially when you get on these bigger tables. So we do tables that are 48 by 96. We've done them up to 120, done them beyond that with seams in them, but it's really always the discussion of how we're going to reinforce the top. We can get the stability out of the legs, but we don't want the bowing in the top. And really think about what you're going to put on these. Like, even if you get a lot of reinforcement on the top, I really don't recommend starting doing like long runs of dedicated computers on these. That's what a benching system is for. Or if you have a culture that you know has a high propensity to sit on tables, with many people sitting on the tables at one time, you want to kind of think this through. So that is one of the limiters with it, is that you have to kind of think about the weight that's going on to the table. It can be managed, but it's a question you should dive deeper into. Okay, so getting into chairs here. Again, keeping it at a high level, looking at basic instruction of side chairs and lounge chairs. Now, side chairs are a really broad category. So obviously you're going to find a wide variety of materials that you can construct these out of: wood, laminate, upholstery, plastic. For the seat in the back, the bases could be wood, metal, or plastic. Agati does not really do any poly or plastic seating. It's just not kind of in our product line or in our wheelhouse in there. And then lounge seating. So lounge seating being a little less broad, but basic construction. It's not complex. You're gonna have a back, a seat, and some kind of base, and that's usually going to make up almost all of these chairs. Now that shape can, those shapes are going to come in a variety of different materials and things, and you can do a lot with it, but that's going to be the basic kind of construction of these at a high level. A little deeper, going into the lounge world, you're going to have kind of a subframe material and then foam going on top and upholstery. This all seems pretty obvious, but the reason why we just want to point this out, because when we get a little deeper into recommendations and vulnerable points, we just want to have everybody on the same page with construction terminology. The frames, again, plywood, solid wood is a common construction method. Metal is a common construction method, and plastic too. These are typically your three different ways that you're going to kind of construct an inner frame of those lounge chairs. And then what you run into is either like a layered foam process. Now the picture on the left here is even a more simplified way than we do our foam. It's just kind of just to cut out some of the visual noise, but you'll take a multi-layered kind of foaming approach to it versus a single density, maybe molded foam or just cut foam on board. Usually the kind of two variations you're going to run into in there. And then upholstery. Now upholstery can get pretty broad, but basically like what you're going to have tight fit, which is basically components that are kind of fully wrapped, stapled, and connected together. Or you're going to have maybe a combination of tight fit and loose cushion in there, where it's like a pillow or something like that that's been upholstered in there and then either loosely put in or attached into the seating. And then stitching, again, you can go down a deep rabbit hole of stitching, but you're going to run into a single stitch, top stitch, double stitch, double top stitch from stitching profiles in there. Lots of times you're not really going to get too far into the weeds, especially when you're looking at evaluating or speccing furniture, but sometimes in the public space environment, the reason I bring it up is it can matter. And we'll talk about that in recommendations. So are these vulnerable? Well, the side seating, again, very broad category. Seat and back, obviously from people, right? People are going to abuse and come in contact with the seat in the back the most. And then really the joinery on there. So thinking about how people are going to tip the chair. I'm a chair tipper myself, so I'm guilty of that. I like to lean back in the chair and sit back into it, but it puts a lot of strain on those joints. So people is going to be, again, public space environment, that they're going to be your most abusive. When it comes down to then cleaning and food, especially if it's like these side chairs sometimes have upholstery, quite lounge chairs, but they are side chairs with upholstery. Again, the food service in the area is going to cause extra wear and tear on it, while even though it's driven by people. And then the cleaning. So even if it's wood or upholstery, that cleaning could put a lot of wear on that seating in there. And then again, the joints, people, right? People are going to abuse the furniture. Chairs are light enough that they can tip them, they can drag them, they can wander around spaces. They're highly movable. So again, people are going to be put the most strain on those joints. When it comes to the upholstered seating, the lounge, obviously people are going to affect the frame the most and then affect the foam the most, right? Everything else is going to affect the upholstery. And so this is the challenge that we'll run into. And that's why we kind of broke out fabrics, is that we can do a lot to strengthen the frame. We can do a lot with the foam, and then the fabric goes on top. And it's probably the weakest part of the seating, but yet the most vulnerable. People just sitting on it, rubbing stuff on it, with cleaning, food service, spilling stuff on it, getting crummies all over it, whatever it may be, that trifecta really hits the fabric pretty hard in there. So what do we recommend? With the side seating, especially if it's wood, looking at the joints, even if it's welded, we're giving some examples of wood here. Mortise and tenon joints are really great for seating. You can even take the extra step of having them pinned in there as well to strengthen up that joint. Adding stretchers in the chairs. Not all of our chairs come with stretchers. We do make a fair amount of wood stacking chairs, but stretchers add a lot of strength to the chairs. So I guess if you're really in a kind of a situation where you're saying like, well, do we really need stack or do we really need strength? You're kind of giving up one or two. Not that you can't make a wood stacker stronger, but the stretchers are going to make that wood stacker even stronger in there. So it's not a must-have to have those stretchers, but just maybe wanted to have that conversation. If it's a really, really, really heavy use or abuse environment, you may want to consider having a lower stretcher in there. When we get to upholstery, so really we recommend on the frame side having 7/8 inch to 1 inch thick hardwood plywood, like a grade A hardwood plywood or hardwood itself. Metals work very well too. They still have their own vulnerabilities. Make sure you're using the right gauges and things like that. But metal's another great material. We don't really recommend plastic inner structures. One, it's hard to get the strength out of them over time. So foam, we tend to take the multi-foam approach. So that's kind of what our recommendation comes from, looking at different densities of foam on the chair to both balance out comfort and look and durability, really trying to hit that sweet spot in there. So looking at medium density foams, high density foam, structural foam, really to try to keep that, balance out those three things in there. So a multi-foam approach is usually what we're recommending in there for folks. We don't really recommend loose pillow cushions. We do approach things with a tight fit. There's cons to that. It can make it a little harder to maintain. Talk about that in maintenance. But loose cushions, again, can wander in a public space environment, but they tend to break down a lot more because it's usually just like foam with some batting and other stuff in there, and they kind of just gotta lose their shape over time because again, it's gonna be a high use. When you're at your home or in your office, that's great. But when you're in an airport and you got millions of butts going through your seats, having those loose cushions in there will show their wear a lot faster. So tight fit upholstery, and then just going to the stitching, the top locking stitch. We don't do a top stitch on everything, but we do it on a lot of seams. Again, it helps clean up the seam, making sure it's a locking stitch. So sometimes people will say, "Oh, we noticed a little thread." Well, that could just be where the thread ran out. But if you pull on it, it doesn't pull. It's locked in there. So you can just clip it off. But that really helps hold that seam together. It's very, very rare we ever have a seam just pull apart. Not to say that things happen in production, but it's extremely, extremely rare that seam will pull apart because of that locking stitch. So going into workstations, so looking at basic construction, we're gonna talk about workstations. We put carrels in there. The reason why we kind of separate or we're kind of put these together, carrel is a common, for those that may not work in libraries, carrel is a common library type product. More often people are seeing workstations that are working in office environments, but they serve a similar function. And not the only, but one of the differences is a carrel workstation you sit in and a carrel you sit at, but providing similar functionality. So the workstations being, keeping in mind that, what we kind of talked about from a seating, upholstery standpoint, especially what we talked about from a table standpoint, all apply to here because you're going to have a seating component, you're going to have a work surface component. The addition is you're adding a screen into the mix. Carrel, again, same idea. You're gonna have a work surface component, so same kind of principles apply. Talking about recommendations, but then you're adding that screen element in there. So are these gonna be vulnerable? Carrels, beyond the work surface, now you're adding a panel in there. So edges, again, come back into play. Thinking about how to protect those edges, that's gonna be the most vulnerable point. So what do we recommend? So on the carrels, I just don't see a lot of upholstered carrels. We'll talk about workstations in a minute. So usually it's a harder surface. Laminate veneer, both work. I know sometimes people push back on the veneer, like, oh, what about people bumping into it? It's extremely rare we're having to build new panels for somebody due to a wear and tear issue. It's usually the tops, to be honest. The panels, even when they run to the floor, they just don't get that much abuse. Work surfaces, again, laminate. PVC edge is great, but sometimes in the carrels, because they can skew a little more traditional, we'll do laminate and solid wood edge in there as well. And then again, the edge, protecting that edge in there. So 2 mil PVC edge with 1/8 inch radius, wood or metal like you see here, this is a metal edge. The reason why in this example we used a metal is because as those panels are thicker and curved, we couldn't put a PVC edge on it. So that was some of the driving factor in there. Can be some of the limiting factor, maybe sometimes why you want to go to a wood edge is because you want that thicker profile, and it's really hard to get PVC much wider than inch and a quarter. So that's why we'll either use wood or metal in those situations. Also, this, you can't really bend it. So since that's a little more organic form to it, we couldn't use PVC. And then for the workstations, so this is a little counterintuitive. I want to start with the screen, and that most people say, oh, it's like a high touch area, so I want a coated material. In all the woven screens that we've done on like this particular product for over a decade, it's been extremely rare we've ever had to replace a screen due to wear and tear on it when it's a woven. When it's a vinyl or a coated material, vinyl, polyurethane, silicone, or whatever, we've had to do more, replace more screens from the bump. So wovens do well in like bump kind of protection, and they're going to be in high traffic passing areas. And then the seats do well with being coated because again, it's a high touch. So you're going to sit on it, you're going to scoot on it, you're going to spill stuff on it. So it does seem a little counterintuitive, but over the decade of making like this product specifically, the wovens have always worked out well. The coated, so it worked out well on the wovens for the screens, coated on the seat and back. And then again, laminate for the work surface. You can do woven on the backs. Again, that's a common upholstery kind of technique with seating, is that you can kind of split those materials in there and tend to, do it on the back is a good place for it if you want to introduce a second woven into it. So fabrics, like we said, we separated fabrics out just because they can be kind of complicated in there, and they're the most vulnerable part on upholstered construction material, furniture. So looking at called basic construction or makeup, and again, a big bucket world, you're going to have some kind of woven. You're going to weave fabric together, and those materials can range from natural materials to polyesters, things like that. But they're going to be fibers woven together. Next being coated. So you're talking your vinyls, your polyurethanes, your silicones, some kind of coated material. And then we'll call it your natural, like your leather, right? It's a natural material. How all these fabrics are evaluated is from a double rub test, and it's put on a Weizenbeek machine, sometimes called the Weizenbeek test. And so what it does is it takes a piece of fabric, it puts it on this wheel, and then it has a cotton cloth that goes over top, and the wheel goes back and forth, and then rubs, and then until it shows wear, however many times it takes, it'll say that's how many double rubs it is. So it'll rub, it'll be 50,000, 100,000, 200,000, a million, whatever the rating is. So that's how it's tested. People put a lot of emphasis on this durability test. We're going to talk about that, but I want you guys to know where this is coming from. So how are these vulnerable? Obviously, people are sitting on it, people are touching it. They're going to be the most abusive to it. One thing I want to point out, though, is the food is going to affect these a little differently. So coateds are great for resisting like food type areas. You can wipe them down pretty easily. They don't absorb stains really. The wovens and the leathers are going to wear a lot differently and a lot harder with food. The tricky part is, while the coated materials can be wiped down easier, the wiping can sometimes also degrade the fabric the fastest. So really where these be, and all fabrics can run into this issue, cleaning it can be the most devastating to the fabric itself. In the post-COVID world, between people cleaning it with stuff they shouldn't be doing it, now introducing a new environmental behavior of people cleaning, like, customers, passengers, patrons, cleaning it with their own stuff, what they're choosing to use, is a new pattern behavior that we didn't have to really deal with 10 years ago, but is there now in there. So it can be complicated. So what do we recommend? So we're talking about seating and, fabric usage on seating. And then we talked a little bit about workstation, but going back to the seating here. So a coated or woven is great on the back. Like I said before, using a coated material on the seat works well in a public space environment. Leather works. We also work with a which kind of falls into, doesn't really fall into an exact bucket like we've been using more, it's called an e-leather. It's a reconstituted leather product, so it's actual leather in there, but it's then taken scraps and reground and turned into a roll. That's great on the seats as well. And then again, we talked about the stitching being the top lock stitching in there. With fabrics though, I really want to like polyurethanes and I really want to like silicones. We have just not had consistently good experiences with those two fabrics over a long period of time. I will also say in the post Wild West world of cleaning, vinyls can be challenging as well in there. But the polyurethanes still seem to delaminate, the silicones still seem to kind of wear away at the edges in there. I've seen silicones just kind of basically wear down, like the rubber just kind of just starts wearing down to the backer in high use environments. So there's not always going to be a perfect solution. A lot of it we'll talk about when we get to maintenance is having a discussion about how the space is going to be maintained. Also that kind of leather, e-leather type material I was talking about in there. It does do well with resisting cleaning chemicals and things like that. The downside is it's a leather, so it'll stretch over time. And that's one of the limiting factors in there. So it's all pros and cons, but the polyurethanes and the silicones, we really struggle to see really good consistency and performance on them in these high use environments. So going back to this Weizenbeek test, this is the challenge that you're doing double rubs. You want things that, it's a good baseline to start weeding out because there's millions of fabrics out there. So where do you want to start? Well, you want to get stuff that's over 100,000 double rubs. That's a good place to start. So it's a good test from that standpoint. But just because it's got 1 million double rubs doesn't mean it's going to perform amazingly in your environment. Unfortunately, there's really no test that will tell you how a fabric's going to perform in an environment. Internally, we've tried to go on to the level of like making up our own tests. The problem is there's so many variables. It's really hard to build a testing protocol that could be consistent because you're dealing with human behavior. Are they wiping it down with something? Is your cleaning staff wiping it down with something they're not supposed to? And the question is, well, they're not supposed to be wiping down with something they're not supposed to. So how do you test for that? So it can become really hard to figure out. So that's to say not to do it. We have tons of upholstered furniture out there that lasts for decades. It's just really kind of having that kind of complicated discussion. And we'll talk about it in maintenance again, not to repeat myself, about how to clean and manage it. But the Weizenbeek is a great place to start. Things over 100,000 double rubs. It's going to be hard. It's going to be pretty easy to find coated materials with that. It'll be harder to find the wovens, so you can give on that a little bit in there. But if you find wovens with 100,000, that's a good place to start. So let's say in durability is power, right? So the basic instruction being, what kind of power you're providing. So I'm not going to get deep into like, how it's the actual outlets and things are built, but really understanding what are you providing? What do you want to provide to your people? Is it going to be plugs, USBs, wireless in there? And then how is it connecting to the building? Are you going to put it all into a power strip and plug it into an outlet? Is it going to have to be something hardwired? Are there floor boxes, power bowls, things like that? So what kind of power are you providing? So your options are going to be like 110 outlets, right? 3-prong outlets we're all used to. USBs. So USBs are newer in the fact that USB-A has been around for a long time. USB-C, the smaller one, this is pictured with USB-A, is becoming more popular out there. And then wireless charging, which has been around for a bit. It's not quite universally adopted across devices and things like that. It's slow. It is getting better. So it's interesting. We'll talk about that, but these are kind of the options you're going to kind of encounter when talking about power. That's, I should say, power for people to access. And then connecting to the building, usually it's going to be plug set. That may be a term you hear, and that's just putting a cord into the floor or taking a power strip and connecting it and then putting that into the floor. So plug set is usually just referring to like a 3-pronged outlet. And then there's hardwired. And so hardwired being some kind of prefabricated electrical system that's inside the furniture. And then what the key is that that's going to have just bare wires coming off of it, and you're going to make a bare wire to bare wire connection into the building, either through a junction box, a floor box, a wall box, something like that. And that's going to require an electrician. So plug set being as simple as just plugging in the floor. Hardwired means electrician, wire to wire connection. And the reason I bring that up is like, it is very common that people get confused with these. I want to say about 60% of the time we will start off hardwired, and we internally will always ask the question, are you sure hardwired? Are you sure hardwired? It's not to be a nudge, but about 60% of the time we've had people come back like, oh, what is hardwired? After they ask you the 5th time, and we'll say, well, it's wires going into the floor. Like, oh no, we have outlets. I'm like, you don't want hardwired then. So I bring it up just because electrical can be very overwhelming and confusing, and hardwired versus plug set is a very common kind of, I'm not really sure, and it can get confused quite a bit. So in your building connection, you're gonna have wall outlet, floor box option or a power pole are like your big kind of categories. Wall outlet, I mean, wall outlet and junction box could probably be in the same category in there, but then you're gonna have some kind of box potentially on the floor. And again, a power pole. You don't see power poles as much anymore, but they exist. Again, they are ways to bring power into a space that's usually badly needed. So where are we vulnerable here? Well, USBs are very susceptible to breaking, especially the A's. The C's are better, but they are vulnerable. They're just small components compared to a three-prong outlet. We have had a lot of people move away from USBs. We'll talk about that, but that's going to be your most vulnerable kind of like plug-in option. We'll put this in here. It's kind of a weird vulnerability, but like location. So lots of times people will select stuff and then not always think about how are people going to access the power. So for example, if you're doing dedicated computer banks at a library and you don't have power on the work surface, they're going to start climbing underneath there and unplugging whatever they want to plug their phone in there. So not thinking through how people are going to access their devices can create a vulnerability in this. And then flexibility. Flexibility is still important. I think it's hard because we learn a lot, things change. And so we want to be adaptable to that. So sometimes we get a lot of requests to put stuff on casters with power. It's not really what we recommend because you're putting a lot of strain on those cords and power components in there. So again, going to recommendations. 110 outlets, they can be cumbersome because you got to carry a brick, and especially now that people just have cords, you can just plug straight in. But they are very universal and they are extremely durable. Not to say that they don't break, but they rarely break. USBs break a lot. And we've had people now just fully, I'm done with USBs. They're breaking too much. And again, it's probably not from people like gouging them out deliberately. It's just they're smaller components. They just have smaller amounts of metal. It can only take so many ins and outs. So it's just a reality in a high use environment, really thinking through that. We'll talk about that a little bit when we get to maintenance. So it's not to say not to use them, but it's really to ask that question of like, what's the bang for buck with this? Wireless charging, we're not quite there on a recommendation. It is cool if you can afford it. It's a really nice to have. It's not quite universal. It is kind of slow, but it is sleek. It is somewhat maintenance kind of free, right? It's just kind of this thing that goes on top. Not only things are only touching it, they're not going inside of it. So that's a benefit to it, but it's not quite universal. It can be an expense in there. So again, if you're looking for kind of bang for buck, 110 outlets are your most effective in there. Plug set and floor box or power strip and floor box work. Doing the plugging directly in the floor works. Really, it's from a furniture standpoint, it's really what you're trying to do in codes you need to maybe hit or ask questions about. If we're doing floor boxes, we typically recommend doing a recessed box of some sort. It just adds a little layer of protection. There's a circular one here. There's square ones. There's slightly bigger ones, basically having the cord go into the floor and then a cover plate come on top and the cord kind of comes out the side of it or something like that. Those tend to work really, really well in the spaces as a connection point for power. So talked about durability here and a lot about durability. We want to go into maintenance here. And so really it's like we can only make it so durable and we want to try to get that last mile out of the product. So thinking about repairs, plan, and then power. Again, talking about power. It's just a vulnerable point, and it's something you're probably going to have to be constantly maintaining. So from a maintenance standpoint, again, looking at these kind of same buckets here as we kind of looked at from the kind of durability. But first we want to talk about like thinking about the questions you want to ask yourself or ask a client in there. So can it be repaired? Don't just assume things can be repaired. Really, like, how could we repair it? Can it be broken down? Can it be taken apart? Can I buy new components for it? Do they stock new components of this? Or am I just have to buy a whole new thing? Sometimes the answer may surprise you. What's the plan? Do I have a maintenance plan? Do I have a maintenance budget? Designers, if you are working with a library, sometimes they may not have a budget for maintenance. And so how do we factor that in there? So they really can only spend money maybe once a year in a capital way or something like that. And that may decide on how you kind of plan and strategize with your furniture. Do I have staff? So we could have a maintenance budget, but who's going to do it? Is it literally going to be the library staff? Is there maintenance staff that are a little more handy? Not a knock against folks in the library, but if you're hiring people that are there to be mechanically inclined, obviously you're going to have a greater ability to maintain stuff. But if you're relying on internal staff to do that, then you may have more limitations. So thinking about power, again, what kind of power do I want for customers? Do I want something that's hassle-free and fairly universal, or do I want to offer a lot of options, but may require more maintenance? Is it hardwired or plug set? What do I really need in that environment? How's it going to connect to the building? Again, this is where is it hardwired or plug set connecting to the building? Are we going into floor boxes? What are the floor boxes? I think the reason I bring it up is floor boxes really become afterthoughts, but they are really, really critical. And it's not like once they're there, it's not like you can change them easily. Really thinking about what and how this is going to work in there. Again, I like the ones that have recessed connections in there. How's it going to run through the furniture? Right? So sometimes, there is a plan, sometimes there's not a plan of how it's going to kind of connect through the furniture. So looking at tables from a maintenance standpoint, so there's going to be connection points and then again, power, right? Power, power, power. So tables, they don't move as much as like seating and stuff. So tables that have kind of like mechanical fasteners and things, if you notice your tables are wandering around a lot, yeah, you're going to want to check those mechanical fasteners, make sure, you're not getting wobble and racking in the table. They're big, long tables, like in reading rooms, like they're going to stay put. As we notice, people have been scaling down table sizes, again, building on that kind of flexibility in a space. Flexibility also means more moving, and again, checking those kind of mechanical points. But the power, really, that's like going to be the thing you're maintaining on the table the most. If you're selecting right work surface for your environment, the power is going to be the thing that someone's connecting into, connecting out of, connecting into, connecting out of. So that's probably going to be the thing that needs going to come out in and out of the table more frequently than anything else. How is it going to be maintained? How is it accessed? Do I need tools? Again, this goes back to the higher questions. If I only have staff that is, again, managing the space, managing a library, managing a school, something like that. And they're the ones that are required to change these parts. I need something simple, easy to access, and maybe tool-free. We have maintenance. Okay, maybe a cover plate can be removed. Maybe it doesn't have to be, thumb screws. Maybe a screwdriver can be used. And there you can get into very, maybe a little more layers of complexity. Even if you have maintenance staff, you don't want it to be too complex, right? Because that becomes a, hassle for someone to change in there. But thinking through those questions. So chairs. Again, looking at the connection points, chairs wander, see more than tables. So you could, you will run into things that could loosen over time. And then the big thing is the upholstery, right? That's, like we said earlier, is going to take the most abuse. Whether it's the side seating or the lounge seating, looking at those connection areas, mostly going to be, base to legs, or excuse me, base to the seating component. That's really where you're going to kind of get your most loosening of components in there. When it comes to the upholstery, having the ability to take the furniture apart makes things easier from cleaning, maintenance, and a reupholstery standpoint. So asking the question of like, hey, can this deconstruct? Even if you don't have a high abuse environment, but like what happens if someone, runs a chair into the side of the arm? Are you tossing out that whole chair, or can you, maybe it could be complex, but can you replace that arm or reupholster that arm in there? Having that ability to take it apart gives you that flexibility over time. So using high quality durable fabrics, obviously, so having that deep fabric discussion with suppliers, designers, fabric manufacturers to really understand what fabric's going to work in the space. Understanding cleaning protocols, how the fabric should be cleaned, and then you may want to tell people not to clean the furniture. And this is something I didn't really think I would have to say 6 years ago. Now I'm just noticing it more and more and more, that there's just a tendency to wipe down. And I thought it would have gone away by now, but I don't think it is. Maybe communicating that into the space. That can be hard. And again, it's in some of these public environments like an airport or a high use library, it's really hard to control people's behavior. So that becomes the complex part. So fabric. Again, going deeper down this rabbit hole of fabric, things to consider about cleaning here. So what is on the cleaning guide? Every fabric has a guide that tells you how it can be cleaned. If you don't have it, you should ask for it. Every commercial fabric should have this. Who will be cleaning it? Again, internal staff, hired, outsourced people. What else will be on the cleaning cart? So once we determine who's cleaning it, then we know who to have the conversation with. What else is on this cart? Because lots of times the spray bottle for the sink in the bathroom is right next to this bottle of water that is meant for the seating, and the same rag is used. So it's really having that kind of conversation in there. How can we stop people from using certain cleaning products. Again, people being the cleaning, not so much the people using the environment, but the people cleaning the space. What steps can we take in there? And so I know we're spending a lot of time on fabrics, and I'm not saying not to use upholstery stuff. And we have tons and tons of insulation that the upholstery lasts for long periods of time. What I do notice is that when people are asking or understand these questions, or when I go to ask them about these, they have answers to them. That seems to be the unifying factor in there with managing fabric and upholstery. So cleaning guides, again, every fabric's going to have some kind of cleaning guide. It's going to tell you what you can put on there. The thing is that just because it's bleach cleanable doesn't mean you can just use bleach all the time on it every single time and just leave it on there. More often than not, they want you to, like, you wash a dish, you want to wash it with something and then rinse it off. So don't plan to bleach clean it every day. Maybe you're going to bleach clean it like only when something happens or once a month. But then when the bleach cleaning is done, you're going to clean the bleach off or whatever you're putting on there. Most of the fabrics are pretty resilient to what goes on it instantly. Where it happens is when it goes on instantly and stays and stays and stays, and that kind of happens and doesn't come off, that's where it starts to degrade. So just keep that in mind. Power. Things to consider about power maintenance is how, again, we talk about how easy can it be accessed? Do you need tools? So again, how is it being accessed in the pieces, whether the table or seating or whatnot? How is it running through the furniture? We talked about this, so just understanding, like, what does it mean? Like, one here is a different as a carrel that we make, and you can do all these different options. So just understanding, like, what is the path that I may have to unwind to get this component out of here. So just going through things at a high level, talking about durability and maintenance. Before we wrap up, though, I don't want to just leave and say, hey, this is the only things we got to consider when thinking about public space furniture. There's still aesthetics. And the reason why I usually end a lot of presentations talking about that, because the visual side of the environment does matter, and it matters a lot. So we think about these spaces from the scale of residential abuse to prison industry abuse. Public space falls pretty close to like prison industry. But now we don't want like prison industry furniture inside of our beautiful public space environments, right? We want them to be warm and inviting and exciting to come to. So, we are creatures that look for things we deem beautiful. And so if we see a space that doesn't seem inviting visually, it all kind of degrades down. And that's why we talk about durability and maintenance, because we want to set it up that maybe you're making a little bit of a aesthetic sacrifice in the beginning, but that furniture, that piece is going to look way better for a much longer period of time. And then if it does start to degrade, you will be able to maintain it and start to bring it back and keep the beauty of that environment in there. So while we tend to choose mostly on aesthetics, nothing wrong with that, but in a public space environment, it does present its challenges. We really need to think about durability with these public space environments, but aesthetics matter, right? We want the stuff to look good over a long period of time. So finding the right balance is the key. And just thinking through those durability, asking those questions, getting into the weeds a little bit will help balance all that out. So I appreciate everybody's time today. If you've got questions, please let us know. Thank you.